When night falls and sound withdraws, the archive remains. The night is long, the air is still. Only what must continue, continues. The surface is not the color it began as. What began as the warm red gold of new copper, the color that copper is, the color that light finds when it meets this metal freshly, before time has had any say in the matter, has become something else, not all at once, not by any single event, by a sequence of changes so gradual that no one moment of the change was visible, each step imperceptible, the accumulation detectable only in comparison. What the surface was against what the surface is now. The metal beneath is unchanged. The copper in the interior of the object, below the depth the air has reached, untouched by the years of atmosphere, retains its original character, its color, its properties, the material as it was when it was cast or worked into its current form. The interior has been held in place by everything that formed above it. The interior knows nothing of what has happened at the surface. The surface knows everything. The surface is where the atmosphere arrives, where oxygen meets copper, where moisture, carrying dissolved carbon dioxide from the air, contacts the metal, and the chemistry that the contact makes possible begins. The surface is the boundary where the metal and the world negotiate, where the conditions outside meet the material inside, and the result of that meeting accumulates layer by layer into what is now visible as color. True wisdom cannot be captured in words. It is found only in the silence between them. The first layer formed quickly, as these things go. Copper in fresh air oxidizes. The outermost copper atoms bond with oxygen, forming a thin film of copper oxide within hours of exposure. This first film is too thin to produce visible color. The underlying copper still shows through, the red gold still present, the change detectable only by instruments sensitive to the chemistry of the outermost atomic layers. The metal appears unchanged. The change is already underway. The first oxide layer alters what comes next. Copper oxide is not copper. It does not react with oxygen the way copper does. The oxide surface is less reactive than the metal surface, the bonds already formed providing less opportunity for further bonding. The reaction slows not to zero, but to the rate that the new surface permits. Oxygen must now interact with an oxide surface to continue the transformation, and the oxide surface presents fewer available sites for reaction than the metal surface did. The rate of change decreased because the change had already occurred. What follows depends on what the air brings. Moisture carries what the atmosphere contains, dissolved gases, the residue of distance, whatever the air has passed through on its way to this surface. These arrive at the metal in solution, react with what the oxidation has already built, and leave their own compound in place of what they found. Each compound is a different color. The first change darkens, brown deepening toward black at the points of greatest exposure, the earliest record, the oxidation that came before anything else. Then, given moisture and time and the carbon the air carries, green begins to appear, not all at once, not evenly, but at the places where conditions were most favorable, spreading outward from those points as the years accumulate. The green deepens where the moisture consistently gathered. Near the sea, there are blues in it. In cities, other compounds enter the record, other colors, the atmosphere writing its particular chemistry into the surface. The color of the surface is the record of what the air contained, not the air today. The air across the years the surface has been exposed, the accumulated atmosphere, the record of every condition the surface has encountered. Urban air leaves a different patina than rural air. Coastal air leaves a different patina than inland air. The same metal exposed in different places develops differently, the variation in color and texture encoding the variation in the atmosphere each surface has experienced. The surface does not describe where it has been. It becomes where it has been. Breath enters. Breath leaves. Between breaths, the air holds its density. The color is not uniform across the surface. Where moisture collected, in a crevice, at the base of a relief, in any depression that held water longer than the flat surrounding surface, the reaction proceeded further. The compounds there are thicker, the color deeper, the layer more developed than on the exposed faces that dried quickly after each rain. Where the surface faced away from the weather received less direct rainfall, dried faster, the patina is thinner, lighter in color, closer to the early stages of the conversion. The surface holds a map of its own exposure. Every variation in color corresponds to a variation in the conditions at that location. How much moisture reached it? How long it held that moisture? How many cycles of wet and dry the surface experienced at that point relative to adjacent points? The map is not precise. It does not record individual weather events. It records the aggregate, the tendency, the average behavior of the atmosphere at each location of the surface over the full duration of the exposure. It is a map of tendencies, not events. The deepest green is not where the heaviest rain fell on any particular day. It is where moisture consistently gathered year after year, because the geometry of the surface directed water to that point. A shallow depression, a horizontal ledge, the junction between two planes. These geometries collect water reliably, not dramatically, but consistently, and the consistency accumulates into depth of color that the exposed faces around them do not develop. The patina knows the geometry of the object. Not as knowledge, there is no knowing in copper carbonate, but as consequence, the chemistry ran where the conditions permitted it to run. The conditions were determined by the geometry, and the result is a surface whose color follows the geometry's logic. Where the object collects, the patina deepens. Where the object sheds, the patina remains thin. The surface is a rendering of the object's own form, written in the language of atmospheric chemistry. Over the time the atmosphere has had to write it. Breath enters, breath leaves. Between breaths, the air holds its density. The layers do not simply accumulate. Each layer changes the conditions for the formation of the next. The carbonate layer that forms on top of the oxide layer is less soluble than the oxide. It resists the acid that the moisture carries, resists conversion to other compounds, holds its structure against the chemistry that formed it. Where the carbonate layer is thick and continuous, it slows the reaction beneath it. The acid that would continue converting copper oxide to carbonate cannot reach the oxide easily. the rate of change decreases further. The layer protects what it covers. This is not protection in any design sense. The carbonate did not form in order to protect the metal beneath. It formed because the chemistry of copper oxide in a moist atmosphere containing carbon dioxide produces copper carbonate. The protection is the consequence of the chemistry, not its purpose. The carbonate exists because the conditions produced it. That its existence changes the conditions for what comes next, slowing the reaction, reducing the rate of further change, is not intention. It is what stability looks like from the inside. Breath enters, breath leaves. Between breaths, the air holds its density. A dense, continuous patina layer reaches a point where the surface has changed as much as these conditions will change it. The reactive metal beneath is covered so thoroughly that the atmosphere can no longer easily reach it. Further change requires different conditions, stronger acids, higher temperatures, the mechanical removal of what has formed. In ordinary air, in ordinary moisture, the surface rests at the depth it has reached, not permanently. Conditions change. The patina layer can crack under thermal expansion and contraction, opening pathways to the metal beneath. Mechanical abrasion can remove it. A change in the atmosphere's chemistry, more acid rain, more salt in coastal air, can dissolve compounds that were previously stable. The passivation is not a permanent state. It is the current equilibrium between the metal, its surface layers, and the conditions it currently faces. But in stable conditions, in ordinary air, it holds. The surface has found a temporary rest within its own transformation. Run a finger across the patina surface. The texture is not smooth, the way polished metal is smooth. The patina has its own topography. The irregular growth of the conversion compounds, the variation in layer thickness between areas of greater and lesser exposure, the points where cracks formed and were refilled, the surface of a material that grew by chemistry rather than by working. The texture is fine, mineral, closer to the surface of stone than to the surface of metal. Under the finger, the surface feels like settled time, not as metaphor, as physical fact. The patina layer has mass, has thickness, has the particular hardness of its constituent compounds. What the finger touches is not the copper that was worked into this shape. It is the result of years of atmospheric chemistry acting on that copper. The accumulated product of reactions that ran at different rates in different conditions, each reaction leaving its compound in place where it formed, the whole building up into a layer with its own physical character distinct from the metal it covers. The metal is beneath this. The original surface, the surface that was dressed or cast or hammered into its current form, the surface that carries the marks of the work that made it, is not accessible to touch. It is buried under the patina, preserved under the patina, the same surface it was when it was made but no longer in contact with the air, no longer reactive, held in its original condition by the very layer that formed on top of it. The patina both covers and preserves. What it covers is the original surface. What it preserves is the same original surface. The covering and the preserving are the same action. The chemistry that conceals the metal also protecting it from the further chemistry that would otherwise continue to convert it. True wisdom cannot be captured in words. It is found only in the silence between them. In strong light, a freshly polished copper surface returns light with high intensity. The reflection is specular. The surface, prepared to a fine smoothness, returns light in a coherent direction, the way a mirror returns light, the way any smooth surface returns light, when the surface irregularities are smaller than the wavelength of the light striking them. The color of the return is the characteristic red gold of copper, the light that the copper's electron structure absorbs subtracted from white light, the remainder returned as the color that copper's atomic configuration determines. This surface is the metal's present tense. The patina surface reflects differently. The conversion compounds scatter light. Their crystalline structure, their varied orientation, their surface irregularities at the scale of the compound's own growth, all of these distribute the incoming light across many angles rather than returning it in a single coherent direction. The surface is not dull in any deficient sense. It has its own luminosity, the soft, diffuse light of a surface that does not concentrate but disperses, that does not mirror but absorbs and returns in all directions equally. This surface is the metal's accumulated past. Both are surfaces. Both are the outermost layer of the same object. The polished surface is the metal itself at the boundary with the air. The patina surface is the compound that the boundary has produced over time. One is what the metal is. One is what the metal has become at the place where it meets the world. Neither is more the surface than the other. They are different kinds of surface, different depths of time made visible as color. Breath enters, breath leaves. Between breaths, the air holds its density. The object rests in the still air of this room. The patina surface faces the room's atmosphere. The air at its particular temperature, humidity, and composition. The air that has been exchanged with the outside through the small gaps in the structure. The air that carries what this night's air carries. The chemistry between the patina surface and this air is slow. The surface is largely passivated, its reactive sites occupied, its conversion compound stable under these conditions. What is occurring at the surface tonight is occurring at the rate of geological patience, below the threshold of any change that could be detected by morning. The surface holds, not forever. Nothing in chemistry is forever. Given sufficient time, given changes in the conditions, a century of rain more acid than tonight's, a different atmosphere, the simple mechanical wearing of what passes near the surface. The patina will change further. The compounds will convert to other compounds. The layer will grow or be removed. The chemistry will proceed in whatever direction the future conditions determine. Tonight the conditions are stable. Tonight the surface is as it is. Tonight the object rests in the color that the years produced, holding that color the way all things hold their current state. Not by effort, not by decision, but by the simple fact of being what the time made them, in the conditions that currently surround them, until the conditions change. The green that is visible at the surface is the same green that was visible last year, the same green that will be visible next year, the color of a compound that has reached the stability its chemistry permits in this atmosphere, the layer beneath the green, the darker oxides closer to the metal, the transition zone between the original surface and the outermost patina, holds its own colors in the dark, invisible but present, the earlier record beneath the later record, the first years of exposure below the decades of slow stabilization. The object is a stratigraphy, not the stratigraphy of rock, which records millions of years in layers of sediment, the stratigraphy of a single object's exposure to a single atmosphere over the years of its particular existence. Each layer is a period. Each color is a chemistry. The sequence from metal surface outward to outermost patina is a sequence in time. From the moment of making to the present, each layer the record of the conditions that formed it, all of them present simultaneously in the cross-section of a surface too thin to see with the naked eye. The layers cannot be separated without destroying what they record. To remove the patina is to remove the record. The original surface would be exposed, clean, reactive, the copper as it was before any of this began. But the record of the years would be gone, the compounds dissolved or abraded away, the chemistry that took decades to produce undone in an afternoon. The original surface and the record of time cannot coexist if the original surface is to be seen. One must be sacrificed for the other. Most objects are not stripped. Most objects are left. The patina remains because removing it would cost what it contains. What it contains is not beauty in any simple sense. It is information. It is duration. It is the physical record of the object's particular existence in its particular place over its particular span of years. To remove the patina is to choose the original surface over the history of the surface. The choice is irreversible. Once the patina is gone, the decades it recorded are not recoverable. The patina is not what was done to the object. The patina is what the object and the world made together, at their boundary, over the time they have been in contact. The object provided the metal. The world provided the atmosphere. The boundary between them provided the conditions. What formed there formed because of all three. And what formed there is now the surface, is now the color, is now the layer that the finger touches when it moves across what has become of the original metal's face. The surface that took time is the record of the time it took. True wisdom cannot be captured in words. It is found only in the silence between them. When night falls, the archive remains. When night falls and sound withdraws, the archive remains. The night is long, the air is still. Only what must continue, continues. Fiber floats in water, not sinking. The individual strands are too fine, too light, their surface area too large relative to their mass for gravity to draw them down quickly. They suspend, they drift, they spread through the water column in response to the currents that stirring produced, moving apart from each other, occupying the space the water offers, distributing themselves through the liquid with a tendency toward evenness that no hand directed. The water holds them apart. Each fiber carries a faint electrical charge along its surface. a consequence of the fiber's own chemistry, the particular arrangement of molecules at the interface between the cellulose of the plant and the water surrounding it. The charge is the same sign on every fiber. Same charges repel. The fibers push against each other gently at the scale of the distances between them, not touching, maintaining a spacing that the charge enforces without any mechanism more complex than the basic physics of like repelling like. The suspension is a preparation. The fibers are not yet paper. They are the material of paper, held in a state of readiness by the water, distributed, separated, suspended in the medium that will, in the next step, be removed. What the water has done is give the fibers space. Space to spread. Space to be individual before they become collective. Space to be arranged by the water's own currents into a distribution that the water, in leaving, will fix. True wisdom cannot be captured in words. It is found only in the silence between them. The frame enters the water from below, a screen of fine mesh stretched across a wooden frame. The mesh woven finely enough that water passes through it freely, but fibers, if they arrive lying flat, will be caught. The frame moves upward through the suspension, lifting a thin layer of water and whatever the water carries. The angle of the lift, the speed of the lift, the depth from which the lift began. All of these affect what the screen captures and how the fibers on it are arranged. As the frame clears the surface, water begins to drain through the mesh, downward, drawn by gravity, carrying nothing with it except dissolved minerals and whatever particles were too small to be caught. The fibers remain. They were flat against the mesh when the water held them there. And as the water leaves, they settle further, their own slight weight pressing them against the screen, against each other, into the arrangement the draining water produced. This moment, between the lifting and the drying, is when the paper's structure is determined. The fibers are still wet, still capable of being moved, still arranged in the configuration that the water deposited them in. They have not yet bonded. They are lying in proximity without commitment, touching without adhering, present in the arrangement that the screen and the water and the lift together produced. What is lying on the screen now is the paper before it is paper. The structure without the bond, the arrangement without the permanence. The bond will come with the drying. Breath enters, breath leaves. Between breaths, the air holds its density. As the water leaves the fiber, something happens at the points of contact, where one fiber lies across another, where the random distribution of the lifting produced an intersection, a crossing, a point where two strands touch. The retreating water draws the surfaces together. The water between the fibers, as it evaporates, pulls the surfaces into closer and closer proximity through surface tension. The same force that causes water to bead on some surfaces and spread on others, here drawing the cellulose surfaces of two fibers toward each other, until the distance between them is small enough for a different kind of force to operate. Hydrogen bonds form, not the bonds of chemistry in the conventional sense. No reaction, no heat, no exchange of electrons. Hydrogen bonding is subtler. The attraction between the slightly positive hydrogen atoms on the surface of one cellulose molecule and the slightly negative oxygen atoms on the surface of another. a weak attraction at any single point, but repeated at thousands of points along every fiber crossing. The aggregate of thousands of weak attractions producing an adhesion that requires significant force to break. No adhesive was applied, no glue, no size, no substance introduced between the fibers to hold them together. The bonding is between the cellulose itself, the same molecule in both fibers, forming the same attraction it forms with itself. The plant material recognizing and adhering to the plant material it was separated from when the fibers were prepared. The paper holds together because cellulose bonds to cellulose across a gap, small enough for hydrogen attraction to operate. The drying made the gap small enough. The water's departure made the bond possible. What was separated in water is reunited in air, not as the plant it came from, which cannot be restored, but as a new structure, flat, thin. The fibers interlocked in the arrangement the water happened to produce. That arrangement now permanent, fixed by the bonds that formed as the last water left. The length of the fiber determines what the sheet can do. Short fibers, fibers that were broken in preparation, or that came from plants that did not have time to grow long, make a sheet that is weak at its crossings. The individual bonds at each intersection are as strong as they would be with longer fibers, but there are fewer intersections per unit area. Short fibers cross each other less often. The network is sparse. The force required to tear the sheet is the force required to break the bonds at the crossings, and with fewer crossings, less force is required. Long fibers cross more often. A long fiber lying across the screen passes over and under many other fibers in its length. Each crossing is a bonding site. Each bonding site adds to the force required to separate the sheet. The sheet is strong not because the fibers are strong. A single fiber is easy to break, but because the network of crossings is dense, the bonds numerous. The force required to tear the sheet distributed across so many individual attractions that no single point bears enough stress to fail first. Strength is the density of the crossings. The density of the crossings is determined by the length of the fibers. The length of the fibers is determined by the time the plant had to grow them. A plant that grew for one season produces shorter fibers than a plant that grew for 3. The difference in fiber length is the difference in growth time, expressed as a structural property of the sheet. The paper that is difficult to tear is difficult to tear because the plant it came from was given time. The strength is the time, converted by growth into fiber length, converted by preparation into suspension, converted by the screen and the drying into a network of bonds. This chain cannot be shortened. There is no method of producing a long fiber quickly. The fiber length is determined by cell growth, and cell growth proceeds at the rate that biology permits, no faster. A fiber that took 3 seasons to reach its length cannot be produced in 1 season by any means available to the maker. The maker can choose the plant, can choose the harvest time, can choose how to prepare the fiber once it is harvested. The maker cannot choose how long the fiber grew, that is between the plant and the time it had. The sheet holds the time it was given, not as memory, as length, as the number of crossings per unit area, as the force required to pull those crossings apart. Breath enters, breath leaves. Between breaths, the air holds its density. Consider the sheet held against light. The light passes through it, not because the sheet is thin in any simple sense, but because the fibers are transparent individually, and the spaces between them admit light, and the sheet as a whole transmits more light than it blocks. Where fibers overlap more densely, the light dims. Where the distribution was thinner, the light passes more easily. The variations in density across the sheet are visible as variations in the light that comes through it. A map of the distribution of the fibers, the record of where the water carried them and where the screen received them. No two sheets are identical. The distribution of fibers across the screen depends on currents too complex to reproduce exactly. The movement of the water during the lift, the angle at which the screen met the suspension, the particular arrangement of fibers in the water at that moment. Each lifting produces a unique distribution. Each sheet is the record of one particular moment of water and fiber, and the hands that moved the frame through the suspension. The moment is gone. The distribution it produced is fixed in the sheet. The sheet is a record of a moment too brief and too complex to have been observed. It happened in the time it takes water to clear a screen, seconds less. In those seconds, the fibers found the positions they would hold permanently. The sheet is what that finding produced. The fibers in their arrangement, the arrangement in its bonds, the bonds in the structure that has held since the last water left the surface. Breath enters, breath leaves. Between breaths, the air holds its density. The plant that provided the fiber is not present in the sheet. The fiber came from a plant, from the inner bark of a particular kind of tree, harvested at the right season, prepared through a sequence of steps that removed everything that was not the long cellulose fiber, the wood, the lignin that bound the fibers together in the living bark, the other compounds the plant produced in its growth, all removed. What remained was the fiber, the cellulose that the plant spent its growing seasons producing, stripped of its context, separated from the structure it belonged to, reduced to its essential material. The plant's structure was destroyed to make the fiber available. Not the fiber itself. The fiber is the plant's structure, in a sense. Each fiber is a cell wall, or a portion of a cell wall, produced by the plant over the time it was growing, built from the sugars the leaves made from sunlight and the minerals the roots drew from the soil. The fiber is the product of the plant's entire existence. It is what the growing produced, at the scale of the individual cell, accumulated over the seasons of growth into the long strands that the preparation isolated. To make paper is to take what the plant spent its life making and rearrange it. Not destroy, rearrange. The cellulose is intact. The molecule that the plant assembled, carbon by carbon, over the seasons of its growth, is the same molecule that now forms the hydrogen bonds that hold the sheet together. The chemistry was not changed. Only the arrangement was changed, from the structure the plant organized it into, which was the structure of a living bark, to the structure the water and the screen organized it into, which is the structure of a sheet. The plant organized the cellulose vertically, along the axis of growth, in the direction that carried water upward and bore the weight of the canopy. The water reorganized it horizontally across the plane of the screen, in a distribution determined by current and chance and the brief moment of the lifting. Both structures are real. Only the second persists. The sheet rests in the dark. It has been holding its structure since the day it dried, since the last water left the surface and the hydrogen bonds fixed the fibers in the arrangement the drying produced. The bonds have not weakened. Hydrogen bonding between cellulose surfaces is stable under ordinary conditions, stable through changes in temperature and humidity, stable through the decades and centuries that well-made sheets of this kind have been known to survive. The fibers do not know they are holding. There is no tension in the sheet, no active force maintaining the structure. The bonds are simply present. The cellulose surfaces in contact, the hydrogen attractions operating across the small gaps between them, requiring no energy to sustain, releasing no energy in their sustaining. The structure persists because the bonds formed and nothing has since provided the force required to break them. What the drying made, the years have not unmade. Outside, the night continues. The air at its particular humidity reaches the surface of the sheet, and some of it is absorbed. Cellulose is hygroscopic. It takes water from the air and releases it depending on the balance between the moisture in the material and the moisture in the surrounding air. The sheet breathes in this sense. It exchanges water with the atmosphere in small amounts, swelling fractionally in humid air and contracting in dry. The fibers responding to the water the air carries with the same affinity for water that made the bonding possible in the first place. The sheet that was made in water has never entirely left the water. It holds a small amount always. The water that the atmosphere provides, the water that the cellulose draws in because cellulose draws water in, the water that sits at the fiber surfaces in a layer too thin to feel but chemically present, chemically significant, the medium in which the hydrogen bonds maintain their operation. The sheet breathes in this sense. It exchanges water with the atmosphere in small amounts, swelling fractionally in humid air and contracting in dry. The fibers responding to the moisture the air carries with the same affinity for water that made the bonding possible in the first place. The sheet was made in water. It was completed by the absence of water. It maintains itself in the trace of water that the air always carries. Each of these is a different relationship with the same substance. The water that held the fibers apart, the water whose departure drew them together, the water that now keeps the bonds operational in the dry air of ordinary existence. 3 roles, 1 material. The sheet is the record of all 3, present as structure, present as the particular arrangement of fibers that these 3 relationships produced and fixed and maintain. Breath enters, breath leaves. Between breaths, the air holds its density. The sheet is here, in the still air. The fibers in it grew in a plant that no longer exists. Harvested, prepared. The structure of the living bark dissolved and separated, and what remained was the fiber, which is here now in the sheet, the cellulose that the plant made present in a form the plant never took. The plant is gone. Its cellulose remains, in the arrangement the water made of it, holding together through the bonds that the drying produced. The fiber holds, not because it was designed to hold, because cellulose in contact with cellulose forms hydrogen bonds, and hydrogen bonds in the absence of sufficient force do not break, and nothing in the ordinary existence of this sheet has provided sufficient force. And so the bonds remain, and the sheet remains, and the arrangement that the water produced in a moment too brief to observe persists in the structure that the moment left behind. The sheet is thin enough that light passes through it. The sheet is strong enough that the light does not change it. Both of these are the fiber, the same length, the same crossings, the same bonds that make the sheet translucent also make it resistant. The transparency is the thinness. The thinness is the spread of the fibers across the screen. The spread of the fibers is the work of the water. The length that allowed the spread to produce strength rather than fragility is the work of the plant, which is the work of the seasons the plant was given. Light passes through the sheet as light passes through water, meeting resistance, losing some of what it carries, arriving on the other side changed by the crossing. The sheet does not hold the light does not hold the sheet. They meet at the surface, exchange what the encounter requires, and continue in their separate directions. The plant gave the fiber its length. The water gave the fiber its arrangement. The drying gave the arrangement its permanence. All three are present in the sheet. None of the three are present anywhere else. True wisdom cannot be captured in words. It is found only in the silence between them. When night falls, the archive remains. When night falls and sound withdraws, the archive remains. The night is long, the air is still. Only what must continue, continues. Inside the wood, there is a shape, not carved in any decorative sense, not an image, not a relief, not a form imposed on the wood for the wood's own sake. A channel running the length of the object, following a geometry that the wood did not originate. The wood was worked to receive this shape. The shape was determined before the wood was touched, determined by something else entirely, something that is not here now. The channel is precise. At its widest point, it is exactly as wide as what it was made for. Along its length, it follows a taper, narrowing gradually from the open end toward the closed, the rate of narrowing matching the rate of narrowing of the thing it was shaped to receive. The inner walls are smooth, finished to a degree that serves a specific purpose. Contact with what enters here should be minimal, distributed evenly, nowhere concentrated enough to produce a mark. The shape exists to hold something. What it holds is air. True wisdom cannot be captured in words. It is found only in the silence between them. The wood chosen for this work is particular, not hard wood. Hardness will work against the purpose. The inner surface of the channel must not resist what enters it or scratch what passes along it. Hardness scratches. What is needed is a wood soft enough to yield slightly at the points of contact, to absorb the small pressures of entry and withdrawal without transmitting them back as abrasion. Not resinous wood, the oils and resins that some trees produce would migrate to the surfaces of the channel over time, would contact whatever rested inside, would leave deposits that accumulate, that alter the surface of what they touch. The wood must be dry in its chemistry, neutral, offering nothing to whatever it holds except the shape it was worked into. A tree that grew in specific conditions, in soil without excessive minerals, in a climate without extremes, at a rate that produced even grain without the irregularities that stress or abundance can introduce into wood. The grain runs the length of the object, not across it, so that the wood's own tendency to move with changes in humidity moves the channel walls together or apart, rather than twisting or warping the shape that was worked into them. The wood was selected before a single cut was made. The selection was the first act of making. Everything that followed, the splitting, the hollowing, the fitting of the two halves around a form, the binding, the finishing, followed from the selection. The wood's properties determined what was possible. The maker worked with those properties, not against them, shaping the channel to the geometry required and trusting the wood's own character to maintain that geometry through the years. Breath enters. Breath leaves. Between breaths, the air holds its density. The channel was made in two halves. Each half of the wood was hollowed, worked from the inside outward, the material removed from the center of each piece until what remained was a shell, thin enough to be light, thick enough to hold its form. The hollowing followed the geometry of what the channel was intended to receive. The depth of the hollow on each side corresponded to half the thickness of that object at each point along its length, so that when the two halves were brought together, the combined hollow would match the object exactly. This required knowing the object before working the wood. The geometry of what the channel would hold had to be understood completely before the first hollow was cut. The taper, the cross-section at each point along the length, the geometry of the tip, all of this had to be known and reproduced in reverse, as a negative space, in the two halves of the wood. The channel is the object's geometry, transferred into wood as absence. Where the object was widest, the channel is widest. Where the object tapered, the channel tapers. Where the object ended, the channel ends. The channel is a record of a geometry that is not present in it. A record made by removing material in the exact shape that the original imposed, so that the original could rest in the removal it required. When the two halves were joined, the channel closed around its own absence. The object for which the channel was made, which had been present throughout the making as the template, the form against which each cut was measured, the shape whose geometry organized every decision, was removed. The channel that remained was the channel that was made around it. The wood held the shape held nothing. Consider the inner wall of the channel. The wood at this surface has been worked to a particular finish, not polished in the way that hard surfaces are polished, but smoothed, the fibers of the wood laid flat rather than raised, the surface presenting the minimum possible resistance to what moves along it. The grain of the wood, visible at the surface, runs lengthwise, parallel to the direction of entry and withdrawal, so that movement along the channel moves with the grain rather than across it. The inner wall is not inert. Wood exchanges moisture with the air it contacts. The air inside the channel, whatever air currently occupies the space, is in exchange with the wood absorbing or releasing moisture depending on the relative humidity of the air and the current moisture content of the wood. This exchange is slow, gradual, a continuous small adjustment between the wood and the air it surrounds. The air inside the channel is not the same as the air outside. The channel is nearly sealed, open at one end, closed at the other. The walls close enough together that air movement through the channel is slow. The air inside changes less rapidly than the air outside. Temperature and humidity inside the channel stabilize at values closer to the wood's own equilibrium than to the external environment. The channel creates a climate for what it holds, not controlled, not designed, but moderated. The wood's own thermal and hygroscopic mass smoothing the fluctuations that the outside air carries. Breath enters, breath leaves. Between breaths, the air holds its density. The outer surface of the object tells nothing of the interior. From outside, the form is closed, a smooth surface, worked and lacquered to a finish that reveals nothing of the channel within, that presents the same face in every direction, that gives no indication of where the hollow begins or ends or how deep it goes. The outer surface is the exterior of the object. The channel is the interior. These two surfaces, outer and inner, are made from the same wood, worked by the same hands, finished with care in both directions, but they face different directions entirely. The outer surface faces the world. The inner surface faces the shape that was made for it. To hold the object is to hold the exterior. To use the object is to encounter the interior. Most hands that have touched this object have touched only the outer surface, have felt the lacquer, the slight warmth of old wood, the weight of the object shifting as it is moved. The interior is accessed only through the opening, only by what enters there, only by the geometry that the channel was shaped to receive. The outer surface is available. The interior is conditional. This condition is the object's primary logic. The exterior exists to be held. The interior exists to receive. The exterior is the visible form, the form that occupies space, the form that presents itself to the room. The interior is the functional form, the form that defines the object's purpose, the form that was determined before the exterior was worked and around which the exterior was arranged. The exterior serves the interior. The interior is not the outside of anything. What the object is for is invisible from outside. What the object shows is not what the object does. Breath enters, breath leaves. Between breaths, the air holds its density. What the channel holds now is only its own geometry. The inner walls face each other across the distance the original geometry required. The exact distance maintained by the wood structure, by the binding that holds the two halves together, by the rigidity of the dried and finished wood that resists the slow forces that would, over years, close the gap or widen it. The walls hold the distance. The distance is the shape. Run a finger along the opening of the channel. The edge is finished. Work to a slight curve. The wood at the rim neither sharp nor soft, but form to a geometry that guides what enters, that eases the transition from outside to inside, that presents the minimum resistance at the point where entry begins. The curve is the channel's first word to whatever approaches it. The opening is here. The geometry begins here. What fits here will find the interior shaped to receive it. The interior does not announce itself. The channel is dark. The walls close enough that light entering the open end does not illuminate the far interior, does not show what the walls look like further in, does not reveal whether the geometry continues as it began or changes in some way that only the inside would show. What the channel is inside, in its full depth, is known only to what has entered it. The opening holds its geometry in the visible inch. The rest is held in the dark. Breath enters. Breath leaves. Between breaths, the air holds its density. The channel has been empty for some time. Not always. There were hours, many hours, most hours, the ordinary hours of its existence, when the channel was not empty, when the geometry of the interior was occupied by the geometry it was made for, when the channel was doing what it was made to do. Those hours are not marked on the wood. The wood does not record occupancy. The inner walls do not show the impression of what rested against them. The wood is too hard for that, the contact too light, the object too precisely fitted for the contact to concentrate at any point. The hours of occupancy left nothing in the wood. What remains is only the channel, the shape that was worked into the wood before the first occupancy, the geometry that preceded every hour of use and will persist through every hour of emptiness. The channel was this shape before anything entered it. The channel is this shape now. The channel will be this shape when next something enters it, if something enters it, the wood holding the geometry it was worked into, regardless of whether the geometry is occupied or not. The shape does not require occupancy to persist. The shape was never dependent on what occupied it, and yet the shape was made for occupancy. Every dimension chosen, every surface finished, every property of the wood selected, with reference to what would rest inside. The shape exists because of what it was made for. The shape persists without what it was made for. These two facts are both present in the channel, held simultaneously in the geometry of the wood, in the smoothness of the inner walls, in the taper that follows the absent taper, in the closed end that corresponds to the absent point. The channel is complete. What would complete it is elsewhere. The object rests in the still of this room. The channel faces upward or downward or to the side. The channel's orientation does not change its geometry, does not open or close the space within it, does not alter the relationship between the inner walls and the air they surround. The channel is what it is in every orientation. The shape worked into the wood, the geometry that preceded and will outlast every occupancy, the record of a form that determined the channel's every dimension without being present in any of them. The wood that holds this shape is old enough that it has settled. Wood moves. It swells and contracts with changes in humidity. It responds to temperature with small expansions and contractions in the grain. It creeps very slowly under the load of its own weight across the years. The accumulated changes are the difference between new wood and old wood. A slight densification, a slight darkening, a slight stiffening as the years of cycling consolidate what the making left loose. The channel through all of this has held its geometry, not perfectly. Wood cannot hold perfectly. The physics of the material do not permit it. But within the tolerance that the channel's purpose requires, the geometry persists. The inner walls are where they were. The taper continues at the rate it was worked to. The closed end remains at the distance from the opening that the original geometry required. Consider what it means for a shape to persist in the absence of what defined it. The channel was shaped by the object it was made for. Every dimension refers to that object. The width of the channel at each point is the width of that object at the corresponding point. The depth of the hollow on each side is half the thickness of that object. The length of the channel is the length of that object from opening to tip. The channel is, in its entirety, a description of something else, a description rendered in wood and absence rather than in words. The thing being described is not here, and yet the description persists, held in the wood with the same fidelity that the wood's properties permit, maintained by the binding and the lacquer and the grain's own resistance to the forces that would alter the geometry. The description does not require the presence of what it describes to remain accurate. It was accurate when the object was within it. It is equally accurate now, the walls at the same distances, the taper following the same angle, the closed end at the same depth, the geometry intact in the object's absence as it was in its presence. The channel is a precise description of what is not here. The precision is not diminished by the absence. If anything, the absence makes the precision more apparent. When the object is within the channel, the fit between them makes the description invisible, the geometry occupied and therefore unremarkable. When the channel is empty, the geometry is all there is. The walls that were background become foreground. The shape that was incidental becomes the object's entire content. There is a particular quality to a space that was made for something specific, a space made for nothing in particular. A room, a box, a container designed to hold whatever arrives, has a different character from a space made for one thing precisely. The general space offers itself neutrally. The specific space offers itself in a particular direction, with a particular expectation, shaped by the form of the one thing it was made for and incapable of fitting anything else with the same exactness. The channel cannot hold anything as well as it holds what it was made for. Every other object that might enter would find the walls at the wrong distances, the taper at the wrong angle, the depth wrong. The channel is specific. Specificity is a form of fidelity. The channel is faithful to what it was made for, whether or not what it was made for is present. Fidelity that does not depend on the presence of what it is faithful to. This is what the wood holds. Not memory, not longing. The geometry, preserved with the same care in the empty hours as in the occupied ones. The inner walls no different now than they were when something rested against them. The shape intact, the air occupying the space that the original occupied, the channel holding its description of an absent form with the indifferent precision of material that does not know what it holds, but holds it exactly. The absence has a shape. The shape has been held since the wood was worked. The wood holds it still, in the dark, in the silence, for whatever comes to occupy it next, or for nothing, if nothing comes. The shape present either way, the wood making no distinction between the hours of occupancy and the hours of waiting. Holding the geometry with the same fidelity it has always held it. Asking nothing of what it was made for. True wisdom cannot be captured in words. It is found only in the silence between them. When night falls, the archive remains. When night falls and sound withdraws, the archive remains. The night is long, the air is still. Only what must continue, continues. A tree is wounded and something flows. Not blood, the tree has no blood, but something that serves a similar purpose in the tree's economy, a thick, milky liquid that emerges at the point of injury, that moves slowly toward the wound's surface, that thickens as it contacts the air and begins, in thickening, to seal the opening. The tree produced this liquid before the wound existed. The wound only provided the occasion for the liquid's emergence. It was already present in the vessels beneath the bark, waiting, though trees do not wait, for the condition that would call it out. The liquid is collected before it seals the wound entirely, scraped from the surface of the cut, gathered in small quantities from each tree, each collection taking what the wound produced and leaving the tree to produce more. The liquid accumulates, grey-brown, viscous, with a particular smell that is sharp and difficult to describe, except by reference to itself. This is the material before it has become what it will become. It is not yet what it will be used as. It is still, at this stage, close to what the tree made it, a defensive secretion, a wound response, a substance whose original purpose was not to be collected, but to seal. The purpose it was collected for is entirely different from the purpose it was made for. True wisdom cannot be captured in words. It is found only in the silence between them. In ordinary air, the liquid begins to change. The change is not drying, not the evaporation of a solvent that leaves a solid residue behind, the way water leaves salt or paint leaves pigment. The liquid contains very little that evaporates. What happens is something else. The molecules in the liquid, in contact with oxygen and moisture from the air, begin to link to each other. Chains form. The chains connect to other chains. The connections multiply. The structure grows denser. What was fluid becomes viscous. What was viscous becomes firm. What was firm becomes hard. Each stage less reversible than the last. Each stage further from liquid, closer to the surface it is becoming. This is hardening, not drying. The distinction matters because it means the liquid does not need to lose mass to become a surface. Nothing leaves. Everything that was in the liquid is still in the surface. The components, the water the liquid carried, the structure that linking built. The water does not evaporate out, it participates. The hardening needs water. In dry conditions, it slows almost to stillness, the linking too sparse to build density. In humid conditions, in air carrying more water than ordinary room air, it deepens. The surface that would take days to form in dry air forms in hours when the air is wet. The surface hardens fastest when the air is most wet. This reverses the usual logic of surfaces, of paints and varnishes and coatings that require dryness to cure, that are ruined by moisture introduced too early. Here the moisture is not the enemy of hardening. The moisture is the condition. Remove it and the hardening stalls. Provide it and the linking continues. The structure grows. The surface approaches what it is becoming. To harden this surface, you close it in with humidity. You make a small, damp dark. You surrender the timing to the chemistry. You wait for the material to do what only the material can do, which is to become, in the conditions you have arranged for it, the surface that the conditions permit. Breath enters, breath leaves. Between breaths, the air holds its density. The chamber for hardening is simple. A box or a room or any enclosed space in which humidity can be maintained at a level higher than the surrounding air. The hardening itself releases moisture, the same moisture the liquid carried, returning to the air of the chamber as the linking proceeds. In an enclosed space, that moisture remains. The chamber holds what the hardening gives off. The hardening continues on what the chamber holds. The two sustain each other, provided the chamber is closed enough to prevent what accumulates from dispersing into the larger air outside. Inside the chamber, there is no light, not because darkness is required, but because the chamber is closed, and a closed chamber admits no light. The surface hardens in the dark, not because darkness hardens it, but because the conditions that harden it, the enclosed humid air, also produce darkness as their incidental consequence. What happens inside the chamber happens without witness. The hardening proceeds at its own rate, determined by the temperature and humidity, and the particular character of this liquid on this surface. The surface passes through stages, tacky, then less tacky, then firm at the surface while still soft beneath, then firm throughout, then hard, each stage less reversible than the last. The stages do not announce themselves. The surface simply is what it is when the chamber is opened, and what it is depends entirely on how long the chamber was closed. The maker closes the chamber and releases control. Not forever. The chamber will be opened, the surface examined, the next decision made. But for the duration of the hardening, there is nothing the maker can do. The reaction proceeds or it does not. The humidity holds or it does not. The surface becomes what the conditions make of it. The maker's last act before closing the chamber was the application of the liquid. The first act after opening will be an assessment of what the liquid became. Between those two acts, the chemistry. Each layer is applied over a hardened previous layer, not simply laid on top. The new layer bonds to the old layer as it hardens. The urushiol molecules at the surface of the new layer cross-linking with the molecules at the surface of the old. The two layers becoming chemically continuous at their interface. The layers do not separate because they are not, at their boundary, separate. They are the same molecular network, formed at different times, joined where they met. The depth of the surface is the number of layers. Each layer is thin enough that the texture of what lies beneath it is not entirely obscured, thin enough that many layers are needed to build significant depth, thin enough that each layer dries, hardens, quickly enough to receive the next within a reasonable interval. Between layers, the chamber, the humidity, the weighting. After each layer, assessment, the decision whether to apply another, the preparation of the surface if another layer will follow. 10 layers, 20, sometimes many more. Each layer added its hardening time, its period in the chamber, its contribution to the depth. The depth of the final surface is not the depth of a single application. It is the accumulation of intervals. Each layer's hardening time added to every other layer's hardening time. The total duration of the making stretched across the weeks and months that the layering required. Breath enters, breath leaves. Between breaths, the air holds its density. Between layers, the surface is prepared. The hardened layer is abraded lightly, not to remove it, but to receive the next. The surface that cross-linking produced is smooth, perhaps too smooth. A new layer applied directly to a fully smooth surface would sit on top without bonding deeply. The interface between old and new too, glassy for the cross-linking to take firm hold. The abrasion opens the surface slightly. It creates the microscopic texture that the new application needs to penetrate, to begin the cross-linking that will join the layers into one continuous structure, rather than two layers in contact. The abrasion is the preparation for trust, not trust in any metaphorical sense. The chemical fact. The abraded surface accepts the new layer in a way the unabraded surface does not. The scratch opens. The new liquid enters the opening. The hardening binds them. The scratch disappears into the bond. What was a mark of preparation becomes invisible in the continuity it made possible. Each layer required the one before it to be complete. Each layer required the one before it to be opened. Complete enough to bear the weight of the next application without deforming, open enough to accept the molecular engagement that would make the two layers one. The timing of each application was a judgment. Not too soon, when the previous layer was still soft and could not bear the next. Not too late, when the previous layer had closed so completely that the new layer could only sit on its surface without penetrating. The maker held this interval by feel, not by instrument. There is no instrument calibrated to the readiness of a hardening urushiol surface. By touch, by appearance, by the accumulated knowledge of what a surface that is ready to receive feels like compared to a surface that is not yet ready, and a surface that has waited too long. The knowledge is in the hands. The hands know what the eyes cannot see and the instruments cannot measure. The making required this, not precision in any mechanical sense. Attention. the specific attention that knows when a material is ready for the next thing to happen to it. Breath enters, breath leaves. Between breaths, the air holds its density. The finished surface is not finished, or rather, it is finished in the sense that no further layers will be applied, no further work done to it, the maker's involvement completed. But the hardening continues. The cross-linking that began when the first layer was applied and continued through every subsequent application has not reached its endpoint. The molecular network that the reaction built continues to become denser, the bonds more numerous, the structure more rigid, for months after the final layer was closed in its chamber. Years, in some cases. The surface that was firm when delivered is harder 5 years later. The object ages into its final form, not as degradation, not as the wearing and weathering and oxidation that time brings to most surfaces, as completion. The hardening that the maker initiated and the chemistry continued reaches, over years, a state that the maker could not have produced directly, could not have accelerated, could only have initiated and then waited for. The final state of the surface is the state that time produces from the state that the maker left. The maker's work and time's work are both present in the surface. They are not separable. The layers that the maker applied contain the molecular network that time densified. The network that time densified is the layers the maker applied, changed by the years of continued cross-linking. The surface is the collaboration, the maker's precision in application, the chemistry's precision in reaction, time's patience in completion. All three present simultaneously in what the hand touches now. Breath enters, breath leaves. Between breaths, the air holds its density. The surface in this room has been hardening since it was made, not visibly. The change that years of continued cross-linking produce is below the threshold of any observation available to the eye or the hand. The surface feels as it felt last year. It looks as it looked last year. But the molecular network is denser than it was last year, the bonds more numerous, the structure incrementally more what the reaction tends toward. The surface is closer tonight to its final state than it was when it was made. Whether it has reached that final state is not knowable. The reaction has no clear endpoint, no stage at which the chemistry announces completion, no color change, no physical event that marks the transition from hardening to hardened. The reaction simply slows, approaching a state it never quite declares arrived at, drawing closer without ever marking the moment of arrival. Whether that state has been reached in this surface tonight is a question that neither observation nor chemistry can answer with certainty. The surface may still be becoming what it will be. Under the final layer, the layer that the eye contacts and the hand touches, the layers below are at their own stages of completion. The first layer, applied longest ago, is the most dense, the most linked, the closest to wherever this chemistry finally rests. Each subsequent layer is slightly less complete than the one below it, slightly more recent in its hardening, slightly further from that rest. The surface is a gradient of completion, the oldest layer's deepest and densest, the newest layer at the surface still, after all this time, continuing. The depth of the surface is the depth of the time that built it. Layer upon layer, interval upon interval, each hardening period laid over the last. To touch the surface is to touch the most recent of many times. Beneath that touch, every previous time compressed into the thickness of what years of chemistry can build. The surface holds the light quietly, not the bright return of polished metal, not the diffuse scatter of matte stone. Something between, a depth in the reflection, the light entering the surface slightly before returning. The return carrying information from the layers below as well as the layer above. This is the quality that many layers produce, not reflection from a single plane, but from a volume. The light sampling the depth before it leaves. The eye receiving not just the surface, but the accumulated thickness of the time that built it. The depth is visible as luminosity, not brightness, luminosity. The distinction is the depth. A bright surface returns light quickly from the outermost plane without entering. A luminous surface accepts the light, holds it briefly in the depth of the material, returns it changed by the passage. What changed the light is the structure beneath the surface. The layers, the interfaces between them, the gradient of density from the surface inward to the base. The light that left the surface passed through all of this on its way in and on its way back. What the eye receives is the surface and everything beneath it, compressed into a single return. The years are in the light, not as memory, as depth, as the particular quality of a surface that took time to become what it is, that is still tonight, in this room, in the dark beyond the light's reach, continuing to become it. The tree was wounded, the liquid flowed, the chamber closed around the humidity, the layers hardened into each other. The years continued what the maker began. None of these are visible in the surface tonight. The surface is smooth, the surface is dark. The surface returns what light there is with the quiet depth of a material that has had years to settle into itself, that has been completing its own chemistry in the intervals between every examination, that is further along its own trajectory tonight than it was last night, by the smallest increment, the cross-linking advancing at the rate that this temperature and this humidity and this particular molecular structure permit. The surface is still becoming, not urgently, not visibly, at the rate of chemistry left to itself, at the rate of a reaction that has been running for years and will continue until it reaches whatever it reaches. Without announcement, without event, in the dark of every night and the light of every day equally. The material completes itself on its own terms, in its own time, asking nothing of the room it is in except the conditions it needs, and finding those conditions here, tonight, as it has found them every night since the maker's last touch, left the surface and the chemistry took over what the maker had begun. The maker set the process in motion. The process does not remember the maker. The process only continues. Layer beneath layer, bond within bond, the reaction that began in a wound traveling forward through time at the pace that chemistry permits, becoming, in the dark of this room and every room before it, incrementally more what it was always going to become. True wisdom cannot be captured in words. It is found only in the silence between them. When night falls, the archive remains. When night falls and sound withdraws, the archive remains. The night is long, the air is still. Only what must continue, continues. The pillar stands where it was placed, not where it grew. It did not grow here, did not send roots into this floor, did not reach toward whatever light this ceiling admits. It grew elsewhere, in soil it will never return to, under a sky it hasn't seen since it was cut. What stands here now is the result of that growth, transported and set vertical, asked to do something the living tree never did, to hold a weight above it, stationary, for as long as the structure requires. The weight above the pillar is constant. Beams, joinery, the layers of the roof and whatever the roof carries, all of this presses down through the pillar's length, arriving at the base as a force that the floor receives through the pillar. The force does not pause at night. It does not reduce in the cold months or ease in the still hours before dawn. It is the weight of what is above, present at every moment of every year, transferred through the wood in a continuous column of compression from the capital to the base. The pillar has been receiving this force since it was set in place. Not resisting it, that framing suggests a contest, and there is no contest here. The pillar receives the force the way the floor receives the pillar, by being present, by having the structure to transmit what arrives at the top to what waits at the bottom, by being the interval between the weight above and the ground below. The force passes through. The wood is not diminished by the passing. The wood is slowly changed by it. And the change is not the same as diminishment, though they can be difficult to tell apart before enough time has passed to see which one it was. True wisdom cannot be captured in words. It is found only in the silence between them. To other chains, the connections multiply, the structure grows denser. What was fluid becomes viscous. What was viscous becomes firm. What was firm becomes hard. Each stage less reversible than the last. Each stage further from liquid, closer to the surface it is becoming. This is hardening, not drying. The distinction matters because it means the liquid does not need to lose mass to become a surface. Nothing leaves. Everything that was in the liquid is still in the surface. The components, the water the liquid carried, the structure that linking built. The water does not evaporate out, it participates. The hardening needs water. In dry conditions it slows almost to stillness, the linking too sparse to build density. In humid conditions, in air carrying more water than ordinary room air, it deepens. The surface that would take days to form in dry air forms in hours when the air is wet. The surface hardens fastest when the air is most wet. This reverses the usual logic of surfaces, of paints and varnishes and coatings that require dryness to cure, that are ruined by moisture introduced too early. Here the moisture is not the enemy of hardening. The moisture is the condition. Remove it and the hardening stalls. Provide it and the linking continues. The structure grows. The surface approaches what it is becoming. To harden this surface, you close it in with humidity. You make a small, damp dark. You surrender the timing to the chemistry. You wait for the material to do what only the material can do, which is to become, in the conditions you have arranged for it, the surface that the conditions permit. Before it was a pillar, it was a tree. The rings visible in the end grain, if the end grain is exposed, if light falls on it at the right angle, are the years of that tree's life, each ring the record of one growing season, the boundary between rings, the boundary between one year and the next. The rings are not uniform. In years of adequate rain and mild temperature, the cells the tree produced were larger, the ring wider, the wood of that year slightly less dense. In years of constraint, drought, late frost, competition from neighboring trees for light and water, the cells were smaller, the ring narrower, the wood denser for the difficulty. The history of the ground where it grew is in the wood, not as memory, as structure. The configuration of cells that each year's conditions produced, preserved in the arrangement of fiber that the tree built. Each ring has two parts. The early wood, produced in spring, when growth is rapid and conditions are generous, with larger cells and thinner walls, and the late wood, produced as the growing season closes, the cells smaller, the walls thicker, the wood denser and darker. The boundary between early wood and late wood within a single ring is the boundary between spring and autumn, between the beginning of the year and its end. The dark bands are the hard seasons. The pale bands are the open ones. Both are necessary to the strength of what grew from them. The years of abundance and the years of constraint are both present, laid concentrically outward from the center, the oldest years at the core and the most recent years just inside where the bark was. The bark itself is gone now, removed when the tree was prepared for this use. What remains is the wood, all of it, every year from the first to the last, standing in the cross-section as the complete record of a life that ended when it was cut and that persists as structure in what was made from it. The center of the pillar is the oldest wood. It grew first before any of the rings outside it existed, when the tree was young and the trunk was narrow. The cells at the center are the cells of the tree's first years, smaller, denser, produced when the tree was establishing itself. Around those first years, the subsequent years accumulated, each ring added to the outside of what existed, the tree growing outward as it grew older, the center remaining fixed while the diameter expanded around it. The core that formed first is now the structural core of the pillar. The years accumulated around it are the body. The years of load that came after are present in both, invisibly, as density within density. Breath enters, breath leaves. Between breaths, the air holds its density. When the tree was cut, the wood began a different kind of change. The living tree moved water constantly. From roots, through trunk, through branches to leaves, the transpiration stream carrying dissolved minerals upward, the wood cells of the sapwood participating in this movement, the heartwood already retired from active transport but still containing the moisture that the living tissue held. When the tree was cut, the movement stopped. The cells that had carried water no longer carried water. The moisture they contained began slowly to leave. Drying is not simple. The water in wood exists in two conditions: free water held loosely in the cavities of the cells, and bound water held within the cell walls themselves. Free water leaves first, evaporating from the surface as the cells empty. When the free water is gone, the bound water begins to leave, held more tightly, releasing more slowly, and as it releases, changing the walls that held it. As bound water leaves the cell walls shrink. The cell walls that were swollen with moisture become, as that moisture departs, thinner, denser, drawn closer together. The spaces that water occupied close. The fibers that ran through the living wood tighten against each other. What was soft with water becomes hard without it. Not broken, not diminished, but compressed into itself. The structure that growth produced now pulled inward by the departure of what growth had filled it with. This tightening is not uniform across the pillar's cross-section. The outside dries first. As the outer wood loses moisture, it would shrink. But it is constrained by the inner wood, which is still wet and has not yet shrunk. The outer wood, prevented from shrinking freely, develops tension at the surface. Later, when the inner wood dries, it would shrink. But now the outer wood has already set, and the inner wood is constrained in turn. The pillar carries this record of sequential drying in its internal stresses. The outer wood in tension, the inner wood in compression, the two in a quiet equilibrium that the years of seasoning established and that the wood has held ever since. The drying took years, not the surface drying. That happens quickly within weeks of felling. The interior of a large trunk dries slowly, the moisture gradient moving from the outside inward at a rate determined by the density of the wood and the conditions of the air around it. The pillar was cut, prepared, and seasoned before it was shaped and placed. The pillar that entered this structure was already different from the tree that was cut. The drying had already changed it. Denser, harder, the internal stresses settled into their long equilibrium, the fiber prepared for what would come next. And then it was placed, and the weight arrived. Breath enters, breath leaves. Between breaths, the air holds its density. Under long compression, wood changes. Not quickly. This is not the change of quenching, not the change of fracture, not even the change of a growing season. This is the change of decades, of the slow response of fiber to a force that never releases. The wood moves imperceptibly in the direction the force applies. Beams sag slightly over centuries. Joints seat more deeply into their mortises. The pillar, compressed from above, becomes over years incrementally denser at its core. The fibers press closer by the weight that never lifts. This is not failure. Failure would be fracture. The sudden release of accumulated stress. The wood unable to carry what is asked of it. What happens here is different. The wood accommodates. the fibers shift into a configuration that distributes the load more evenly across the cross-section. The small voids that seasoning left in the structure close under the sustained pressure. The wood settles into the load the way the load settles into the wood. A mutual adjustment, slow and continuous, happening at the scale of fiber and cell wall, rather than at any scale the eye can follow. A pillar does not resist its load. It becomes the shape that carrying requires. Each year of load finds the pillar slightly different from how the previous year's load found it. Slightly denser, slightly more aligned to the force, slightly more what a column of wood under that precise weight, and in that precise position, over that precise accumulation of time, becomes. The load does not impose itself on a fixed material. The material responds. The response is the structure. The structure is what stands here. The weight does not diminish the pillar. The weight works on the pillar, and the pillar responds to the weight, and over years the response becomes the pillar's structure. The fiber arrangement is no longer only what the tree grew or the seasoning produced, but what a century of compression has made of it alongside those earlier makings. The pillar is the record of the force it has received, written in the density of the wood, in the subtle compaction at the core, in the settling and seating that the years of load have worked into the grain. True wisdom cannot be captured in words. It is found only in the silence between them. Breath enters, breath leaves. Between breaths, the air holds its density. An old pillar carries the record of what it has carried, not visibly. The changes that decades of load produce are not the changes of weathering or wear, not the surface changes that the eye can follow from year to year. They are interior changes, the slow settling of fiber into the direction of force, the gradual closing of small voids in the structure, the grain reorienting itself around the vertical axis of compression. The pillar that has stood for a century is not the pillar that was placed. It is what that pillar became under the specific weight of this structure over the specific duration of this use. The load left its geometry in the wood. Where the force was concentrated, the wood responded to the concentration. Where the load transferred through the joinery, the wood seated itself more exactly into the joint, not loosening, as wear loosens, but fitting more precisely, as sustained contact under pressure fits. The pillar learned the shape of what it carries the way any material learned the shape of the force it receives over time, not by understanding it, but by being changed by it, incrementally, in the direction the force consistently applied. The wood is not diminished by this. It is marked. The record of the load is present in the fiber, in the slight compaction at the core, in the geometry of how the grain runs now compared to how it ran when the pillar was placed, in the way the wood has moved into rather than away from the weight. To carry weight for a century is to become, over that century, a more exact record of that weight. The pillar is not what it was. The pillar is what the carrying made of it. The pillar became what it is by doing what it was placed here to do. Each year of load is present in the structure of the wood, not as a ring, not as a line, not as any boundary visible to the eye, but as the incremental record that a year of compression leaves in fiber, added to every year before it and every year that followed. The cross-section that shows the tree's years in its rings also holds, invisibly within those rings, the years of load that came after. The two timescales layered in the same material, the biological time of growth and the structural time of use, inseparable now in the fiber that both produced. True wisdom cannot be captured in words. It is found only in the silence between them. The pillar stands tonight as it stood last night. There is no visible difference. The compression that this night's load adds to the accumulated compression of every previous night is below any threshold of observation, smaller than the swelling that humidity introduces, smaller than the contraction that cold produces, lost in the ordinary movement of wood through its daily and seasonal cycles. Tonight's addition to the pillar's structure is real and undetectable. It will be real and undetectable tomorrow night as well. The pillar does not accumulate these changes in any way that makes them countable or traceable. There is no record of them except in the density of the wood itself. The wood that is tonight, incrementally denser than it was when it was placed, denser than it was a decade ago, denser than it was last year, denser than it was this morning, by an amount that has no name, that no instrument was built to capture, because it is too small to matter at any single moment and too consequential to ignore across a century. The weight is doing its work at the pace that wood and time permit. Not the pace of the quench, not the pace of fracture or fire, or the sudden crystalline change that a second of cold water can produce. The pace of fiber settling into the direction of force, of cell walls finding the configuration that the sustained load prefers, of a structure becoming, not all at once and not visibly, more exactly what a century of vertical compression asks wood to be. Breath enters, breath leaves. Between breaths, the air holds its density. The weight is doing its work, quietly, at the pace of slow changes that only become visible when you compare across centuries rather than across years. The pillar receives the weight from above and transmits it to the floor below. And in the interval between receiving and transmitting, in the wood itself, the weight leaves its record. Not as damage, not as wear, not as the gradual exhaustion of a material asked to do more than it can sustain. As the deepening of a structure that is under the load it carries, becoming more fully what the load requires it to be. The tree grew toward light for the years it lived. The wood has been doing something else since, drying into hardness, compressing into density, carrying what was placed above it, and becoming, in the carrying, the pillar that the weight required. The tree is gone. The wood remains. The wood is not what the tree was, and it is not only what the tree made it, and it is not only what the seasoning made it. The wood is what the years since the tree made of it, a column of compressed time, standing in the dark, standing in the light, receiving tonight what it has received every night, adding tonight's increment to the total it has been accumulating since the weight first arrived and the wood first answered. The tree spent its life reaching outward. The pillar has spent its life receiving downward. Both movements left their record in the same material. The rings at the core hold the years of reaching. The density that no ring marks holds the years of receiving. Both are present tonight in the wood that stands here. Neither finished, neither separate from the other. The growth and the load and the long accommodation between them continuous in the fibre. Quiet in the dark, bearing the weight of what is above as it has borne it since the beginning, and will bear it until whatever comes after. It will still be standing when this night ends. It will be, by that small and unmeasurable amount, more what it has been becoming. True wisdom cannot be captured in words. It is found only in the silence between them. When night falls, the archive remains.